Okay, I didn't quite finish the material that I wanted to about NumPy on Thursday, so I'm going to do about a 15 or 20 minute video to finish that up. We introduced NumPy ND arrays, which are n-dimensional arrays. We saw that there are various ways you can create ND arrays, such as the aRange function, which creates an ND array with a sequence of integer values. It's very similar to the range function that's built into Python. We also talked about using the np.array function that takes an iterable, such as a list, or down here a tuple, and constructs an ND array from that iterable. We mentioned that every element of an ND array has to be the same data type, unlike elements in a list. And if you use, for example, a list of mixed data types with the array construction function, these int values in this case are going to be upcast so that all of the values in the array are, in the resulting ND array, are floats. Okay, so in one way or another, you have got yourself an ND array, and we saw how you can create for yourself a multidimensional ND array, in particular some two-dimensional ND arrays. You can create 3 or 4 or 5-dimensional ND arrays, but they're a little bit difficult to talk about in PowerPoint slides. So let's move ahead to two-dimensional ND arrays. Here we are. And here I used a list of lists to create a two-dimensional ND array. In this case, 2 rows and 4 columns. I can use the ndim attribute to find out that this is a two-dimensional array, and I can use the shape attribute to get a tuple showing me how many rows and columns there are. Now, in order to, let's suppose that we have an ND array that's very large, and we want to figure out how to get out of that large ND array just the part of the ND array that we want to analyze. Perhaps we have downloaded some huge table from a website somewhere, and we're only interested in several of the rows of the table, or perhaps several of the columns of the table, and we want to know how to pick that big ND array apart into smaller pieces. Well, there are basically 3 approaches to doing that. One approach is to use slice notation involving colons. Another way is to use Boolean indexes involving true and false values to indicate which rows or columns you want and which you don't. And the third way of accessing the part of an ND array that you want is to use what are called fancy indexes. All right, so we're going to illustrate each of these 3 approaches for getting out a subset, a part of an ND array that you want to deal with. Slices we covered pretty well. So for example, here if A1 is an array of 3 rows and 5 columns, this notation here, 1 colon for the rows, means from row 1, row sub 1 I should say, up to the end of the rows. Okay, row sub 1 is actually the second row. So from that row up to and including all the remaining rows. Alright, so we're going to get the sub 1 and sub 2 rows from A1. And then following the comma, we specify which column or columns we want. In this example, the slice colon 3 is equivalent to 0 colon 3, and it means that we want the columns starting from column sub 0 up to but not including column sub 3. So column sub 0 is that one, and we're also going to get column sub 1 and sub 2. We're going to get that for each of the last 2 rows. And so the result is in some sense, the lower left quadrant of that array. Now, it's not really technically a quadrant because I have an odd number of rows and odd number of columns, but as you can see, I get the part of the row, 1, 3, 5, and the part of the row, -5, -4, -3. That is a view on the underlying array A1. It's not a copy. So if I multiply that view times -3, I am going to convert all of these values to -3 times what they used to be. Okay, so this portion of A1, 1, 3, 5, becomes -3, -9, -15, and then similarly, -5, -4, -3 becomes 15, 12, 9. We looked at examples of extracting one-dimensional subarrays out of a two-dimensional array. We could, for example, extract a single row, which gives us a one-dimensional sequence of values, a one-dimensional vector, if you will. Although A1 sub 2 is a vector, it is a view on the underlying A1. So if I say A1 sub 2 to get that vector, and then say sub 1 gets 5, that's going to change the second item of row sub 2 to a 5. And I see that when I display the entirety of A1. If I ask for row sub 2 and all columns, that's really just a more detailed way of asking for the same thing as row sub 2. If I just ask for row sub 2, it's understood that I want all of the columns of row 2. In the example here on slide 54, I'm saying I want from row 2 followed by all the remaining rows. So I'm using slice notation. Now, actually, row sub 2 is the last row in A1, so this is a slice of one row. Seems like it ought to be a vector, but in fact, it's considered to be a two-dimensional array. Notice that mdim is still 2, but it's a two-dimensional array with one row and 5 columns. Here on slide 55, I have all rows and the columns up to but not including row sub 2. So that gives me these first 2 columns of all 3 of the rows. That is the sub 0 and the sub 1 column of rows sub 0, sub 1, and sub 2. That's a 3 by 2 array. All right, now here on slide 56, if we access A1 sub 1 comma 2, we get just this cell from A1, the cell containing -15. And that is a scalar value. It's not part of a vector or part of a matrix. But let's suppose that for some reason we needed to pass this value as a matrix into some library function. We install some library, some package that we got from somebody. One of the modules in there has a function that we would like to call, and the documentation for that function tells us, okay, this parameter has to be a two-dimensional array of values, but we only have a scalar. How can we represent that scalar as a two-dimensional array to pass it in as the proper kind of shape? Well, here's the trick. If I ask for all of the rows from row sub 1 up to but not including 2, that is a slice notation that only includes row sub 1, okay? So it only includes row sub 1, but it is a slice, so it's considered to be a 1 by 5 array rather than a vector. Similarly, if I ask for columns 2 up to but not including 3, that gets me just this particular column of data out of that slice of rows. And although this seems artificial, if I ask for a slice of rows that only includes one row, and within that I ask for a slice of columns that only includes one column, I end up with a two-dimensional array that only contains one cell. So this is a 1 by 1 two-dimensional array containing one value. Okay, so I can use slices to obtain subportions of arrays. Now the problem with slices is that slices are only sequential rows or sequential columns, and perhaps I want to skip certain rows or skip certain columns. For that purpose, I can use these things called Boolean indexes. Here's a Boolean index called B rows, Boolean Row Index. And if I use this Boolean Row Index, what I'm saying is I only want to get row sub 0 and row sub 2. Those are the ones that are true, but I don't want to get row sub 1. And you can see that the result, which remember is a view, only shows row sub 0 and row sub 2, and row sub 1 is left out. In this next example on the bottom of slide 58, I'm asking for all rows using a slice. Colon means all rows in this case. And now I'm asking for just certain columns. I'm using a Boolean index to select just certain columns, and in particular the columns that I want are column sub 0 and column sub 3, and I'm going to skip columns sub 1, sub 2, and sub 4. And as you can see, I do get column sub 0 and column sub 3 out of A1. Again, this is a view. If I apply an equality or inequality or relational operator to a whole ND array, what I get back is an ND array of Booleans. So here's my A1 two-dimensional array, and if I then ask, is A1 less than minus 5, I don't get back a single true or false value. What I get back is a cell-by-cell true or false value. So for all of the cells that are less than minus 5, such as minus 6, minus 8, minus 9, minus 15, minus 15, and minus 9, for these I get back true. All right, for those individual cells I get back true, but for all of the other cells I get back false. And I can use that Boolean array as an index into the original array if I want to just do something to those particular values that are less than minus 5. Here's an example. I'm going to say, in the array A, where the cell is less than a minus 5, change the cell to an 8. And all of those values that were true back on the previous slide, all right, have now been set to 8. All right, so that's an example of Boolean indexes. You can also, as it turns out, use logical combinations, but for some reason you can't use the words and, or, not. You have to use these symbols instead. You use a single ampersand to mean and, a single vertical bar to mean or, a tilde symbol to mean invert or not, and also the caret symbol to mean exclusive or, that is one or the other but not both. Unfortunately, these symbolic operators have higher precedence than the less than and greater than and is equal to and less than or equal to and so on. So you're required to use parentheses if you want to use these logical operators to create combinations of tests. This is annoying, but just a fact of life. Here I have A1 with the changes that I made. So these cells here are 8s. And suppose I'm interested in the cells where the cell is greater than 5 and the cell is less than 9. Well, that turns out to be an error because the and has higher precedence than the greater than or the less than symbol. So in order to not have an error, I must use parentheses around the greater than test and around the less than test. Then I can AND those tests together. Okay, so where do we have situations in here where the cell value is greater than 5 and the cell value is also less than 9? turns out that those are those are going to be all of these 8s. All right, so all of these 8s are greater than 5 and less than 9. And we only have one value other than all these 8s that is true for that condition, and that's the 7. So these cells that I've highlighted here in yellow are the ones that are true. Okay? If I then use that combined Boolean index as a subscript into A1, that allows me to modify just those values for which that expression is true. And what I'm saying here is, let's subtract 5 from each one of those values. Well, the result of that is fairly straightforward. All of these 8s become 3s, and the 7 becomes a 2. So we can see 3s for the half dozen 8s that existed, and 2 for the 7 in place of the 7. All right, lastly, we need to take a look at fancy indexes. Now, slices allow you to ask for sequences of rows or sequences of columns. Boolean indexes allow you to specify subsets of rows or subsets of columns or subsets of individual cells. Fancy indexes allow you to change the order of the selected rows and columns. Let's show an example. So here I'm creating A1. I'm cleaning it up to have some new data to start over with. Let me go ahead and type that in. A1 gets that stuff. So here's A1. And just as a quick review, if I ask for A1 sub :2, comma 3 colon, that's using slices. I'm going to get all of the rows up to but not including row sub 2. I'm going to get all of the columns from sub 3 to the end. So I'm going to get row sub 0, columns sub 3 and 4, row sub 1, columns sub 3 and 4, and that's it. So I'm selecting a portion of the array where the rows and the columns that I'm selecting are sequential. On the other hand, if I say A1 sub all rows true, false, 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 true, that's going to get all the rows but just column 0 and column 4. Okay, so there's a subset. And notice that in both of these cases, the sequence and the Boolean, the result is in the same row and column order as the original array. Now, for the fancy indexes, I can change the orders of things. Here's a simple example. If I say A1 sub, and then for the rows, what I'm going to do is to create a list or an index of row numbers. Let me say 2, 1, 0. What that means is that I want to select row 2, but I want it to be displayed first. Then row sub 1, then row sub 0. So in effect, what I'm doing here is reversing the orders of the rows. I can also repeat rows this way by using fancy indexes. So let me say 2, 1, 2, 1, 2. All right, now I'm going to get no row zeros, and I'm going to get alternating row sub 2s and row sub 1s for a total of 5 rows. Let me just redisplay A1 so that we can compare. All right, so here's row sub 0. I don't have any occurrences of row sub 0. I have the sub 1 and the sub 3 rows in this result are copies of row sub 1 from A1. And rows sub 0, 2, and 4 are copies of A sub 2. I can do a similar thing for columns, so let me say A1 sub all rows, but I only want columns sub 4, sub 2, sub 0, and then sub 1 and sub 3. This is going to preserve all 5 of the columns, but change their orders around. Okay, so I've got column sub 4, followed by column sub 2, and then column sub 0, and then sub 1 and sub 3. Now, If I use fancy indexing for both the row and the column, this allows me to select out individual cells from the array A1. So if I say A1 sub, let's suppose that I want this cell here containing the 3. So that's row sub 1, and it will later also be column sub 1. Then let's suppose that I want this 8 here. That's row sub 0. All right, so I'm going to put a 0 here and column sub 4. And then let's suppose that I want this minus 4 here. So that's row sub 2 and column sub 1. Well, let's just leave it with that for an example. Okay, so now I'm going to get just 3 cells out of A1 using the fancy indexes. And I actually just get a vector of those 3 values. Okay, so that is the 3 kinds of indexing we can do. Slices of rows and columns give me sequences of rows and or sequences of columns. Boolean indexes allow me to select just certain rows or certain columns, but I can't change the order. And fancy indexes allow me to change the orders of the rows and or the columns, and also to just select certain ones and leave other ones out. The final thing I want to mention about NumPy here is that we've looked at how to create ND arrays and also how to extract subsets of large ND arrays. In addition to what we've covered, NumPy provides a huge number of vectorized array functions, so we can ask for square roots and logs and signs and powers. We can ask for statistical values, means, standard deviation, variance, min, max, etc. There are random number generators available for pulling values from a variety of different random distributions. We can do linear algebra calculations, solving AX equals B kinds of problems and diagonalizing matrices and so on. There are sorting and set operations. We can also read in data directly from something like a .csv file or a JSON file into an ND array, and similarly write out the contents of an ND array into various formats of output file. So there's a ton of things that you can find out about in the documentation about how to use and analyze the data that you have in ND arrays.